What you see on the right is the parent function of y equals sine theta. And this is how we're used to graphing our function. Now, today I'm going to show you a different way of graphing, and I'm going to use this problem, y equals sine theta plus 55 degrees, to illustrate that. Okay, given this problem, 55 degrees, the plus 55 degrees in the parentheses means that I'm going to shift left by 55 degrees, angle measure. Now, 55 degrees angle measure, the first, we have to change 55 degrees first to the radian measure. So we multiply 55 degrees by pi over 180. So that cancels our degrees, and we are left with a 55 pi over 180, or 11 pi over 36. Can we graph now? Now, as what I said earlier, I'm going to show you another way of graphing where we will not have our pi's anymore, because we will evaluate every value of our x coordinate. So let's start with our pi over 2. Pi. Okay, pi over 2. Is around 1.57. Pi, of course, that's our 3.14. 3 pi over 2 is around 4.71, and 2 pi is around 6.28. Okay, so now I can graph. Let's see. Use that. And I'd like to use the intervals, 2 spaces for my interval. It's 1, 2, 3, 4, 5, 6. Oh no, I need more. Erase that, and I need more. Okay, this is 7, and my 1 is here, and my -1 is here. What is good about these values is the intervals will be the same for my x and my y. Let me add more here. So that's -1 on this side and -2 there. Okay, now our first step before we can graph is we have to locate where pi over 2 is in our new coordinates, right? So pi over 2 is 1.57, so that's around here, pi over 2. And then 3.14 is somewhere here, 3.14, so that's our pi. 3 pi over 2 is 4.71, so somewhere here, that is our 3 pi over 2. And our 2 pi is 6.28, so somewhere here is our 2 pi. Okay, so let's graph our parent function again, this time using this exact value. So we are going to start with our 0, and then the 1.57 is our max, so right there our pi, 3.14 is 0, 3 pi over 2 will be minimum, so somewhere there, somewhere there, and then the 2 pi is at 0. Okay, so if you connect it, it will still look the same. It's just that we're using 1 as our interval mode. Okay. So now we are ready to shift to the left. But before we do that, let's evaluate what's the value of 11 pi over 36. So 11 pi over 36 is equal to around 0.96, so almost 1. But see, if the value is exact, so like for example 0, right? So I know for my 0, I know I'll be moving almost 1 point to the left. But then for my pi over 2, it's an estimate because it's a 1.57. So it's better for me to subtract from the values here the 0.96. That way it's easier for me. So that's going to be 0.61, 2.18, 3.75, and 5.32. So for my second, since I did my first point already, because that was an exact value, my second point from pi over 2, this needs to go to 0.61. So around here, somewhere there. And then for pi, it's going to go to 2.18, so somewhere there. And then somewhere there. Okay, 2.8, and then 3.75, 3.75, so somewhere here. And the last one is 5.32, so 2 pi is moving to 5.32, somewhere there. So let me connect that. That's going to look like, hold on, it's supposed to be 0.61. Seems like that's a mistake. So see, it's good that we know, because we can easily see that something's wrong with our graph, right? So that's 0.61, so it should be less than 1. 0.61, so somewhere here. Okay, that's about right. So now we are ready to connect, because earlier it was too close to the point. Okay, so that's our final graph. So this one here, one in blue, is our y equals sine theta plus 55. If you have any questions, just leave a comment. And if you need me to solve any more problem, just let me know. And oops, I almost forgot. It seems like I left this out. Okay.